In this video, let's start working on the concept of R squared, and we'll do so by using this graph. So we'll understand what the concept of variation means, and using those concepts we'll be able to define our R squared. Now recall, this is the relationship between education and wage. So based on our sample, we have these blue dots that shows us the actual observations in reality, and the green line is the regression line that we estimate to predict a specific wage. Recall that in reality, we cannot always predict accurately because we have a source of unexplained variation in the results. Since we have specific factors, we have also specific factors for every individual that's gonna make them have higher or lower wages. And to understand it even better, let's work with an example. So I took here a block of observations for a given level of education. So for a given level of education of 10 years, we can see that some individual has an average wage, so has a wage of $1,200, another individual has a wage of $1,900, another individual has $2,100, another one has $2,400, and another one has $3,000. So all the differences that we notice between these individuals in the wages that they earn is due to these specific factors. Some of them are more talented, some of them are less talented. Some of them have better family background, some of them have worse family backgrounds. So the differences that we notice is the difference between the actual observations, between the blue dots, and our predictions, because we predict a specific value, but all of them deviate from that value, and that deviation is explained by something we cannot observe. So we know that in reality we will have this source of variation. This is our first source of variation, the variation of the error term, of the unexplained factors. So let's call it variation of the error term. Variation of error term. Now let's draw this variation to understand what actually is. So the error term is the difference between the real observations and the predicted value. The predicted value is this green dot over here, is this dot on the regression line, and the actual observations are the blue lines, the blue dots, I'm sorry. So the difference between them, it will be these purple lines, and we do that for every predicted value, for every value that we have in the sample, and we add them up. We add them up and square them. We square them because if we do not square them, then these differences will cancel out. Some of the differences will cancel out because we'll have some positive differences, some negative differences, and they'll cancel out. So the effect of those differences will be neglected, and that's not going to be an accurate measure of that variation. So that's why we have to square them. And we do so for all the observations. We want to know the differences for all the real observations from our predicted values. So these purple lines are going to show us just that. We do so for all these dots. So here, 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 and here. So we would actually do it for all the dots, but to save the time, let's just move on. I hope this makes sense. The intuition makes sense. How do we show this in a more mathematical way? What is variation? Variation is always a sum of squared differences. So we have the sum of squared differences of what? Of the error term. So we usually know that as SE, sum of squared differences of the error term. And what did we say? That is a sum. So we know it's going to be a sum. A sum of what? Differences. What kind of differences? Squared differences. And the differences are going to be between the actual observations, the actual wages, minus the predicted wages. So the predicted values we show with this hat, and we said that we square them, so we take them to the power of 2. That's gonna be one source of variation in our model. Now let's leave it like that for this video. In the next video we're gonna have a look at the second variation, a second source of variation, and we'll connect those two to explain the R squared.